In the 1920s, if you wanted a car, you went to a massive Ford factory where everything was built in one place. And for most of the last century, medicine was made in pretty much the same way. In the US, we have big pharma factories that cost $2 billion to start just to churn out millions of the exact same white pill. But as of 2026, that century-old model may be on the verge of a new era. What could be called the iTunes moment for the pharmaceutical industry. One that moves it from the era of the vat to the era of the file. A tiny piece of digital code that could be sent to your local hospital or pharmacy and printed in seconds. In this video, we're going to break down the downloadable drug, why people who control your medicine are working hard to slow down progress of 3D drug printing, and the nightmare scenario that happens when a life-saving heart medication becomes a hackable digital file. For decades, Big Pharma has hidden behind what I'd call the economic iron curtain, a black box of secret rebates and hidden fees that keep patients from seeing the true cost of their medicine. If you look at a drug like Ozempic, it costs less than $5 for a month's supply to make, but many spend over $1,000. Where did the $995 go? Well, it gets swallowed up by drug manufacturers and the army of middlemen, so pharmacy benefit managers and wholesalers who profit from the complexity of moving physical boxes across the country. By 2024, those middlemen had inflated a markup bubble worth a staggering $356 billion a year. And some of this chain justified those high costs through their involvement in cold chain logistics, the hyper expensive refrigerated trucks and warehouses needed to keep drugs from spoiling. It's a very fragile and complex system. Some estimates show that 25% of vaccines reach their destination in a degraded state because of temperature excursions during shipping. But 3D drug printing may make some of these supply chain issues irrelevant by replacing the truck. In 2025, the FDA finalized the FRAME initiative. The framework is designed to eventually turn your local retail pharmacy into a digital print shop. So how does a printer actually make a drug that you can take? Well, unlike factory machines that slam powder into a hard brick, these 3D printers build medicine layer by layer. So there's this thing called zip dose. It works like a liquid glue system. So it sprays a binder onto layers of powder to stitch them together. It'll create a pill that looks solid, but is actually as porous as a sponge, allowing it to melt even in a few drops of water. And this would help somebody who maybe has late stage Parkinson's who can't swallow a traditional pill. They take this porous 3D printed pill, and it's the difference of not taking their medicine or potentially even choking. There's also a semi-solid extrusion, so an SSE. Think of this like a high-tech toothpaste gun that squeezes out medical paste to build an everything pill. Because the printer can switch paste mid-print, they can stack 3 or 4 different medications into one single poly pill. And 3D printing drugs, along with cell and gene therapies, are part of a larger movement where, for the first time in history, medicine is being tailored to the individual and not just some generic one-size-fits-all model. But the first 3D printed drug, Spritum, which I'm probably pronouncing wrong, was actually approved back in 2015. But it stood alone for years because, well, the system is actually rigged to protect the status quo. So the first 3D printed drug was approved by the FDA in 2015. And now here we are 10 years later, and there's not been a ton of progress, or we haven't heard a lot about the progress. A lot of that has to do with something called innovative dampening. Legacy pharmaceutical giants have used tactics like the essentially a copy rule that prevents local pharmacists from printing drugs that are already sold by big factories to keep their patents locked down. Why? Because if a hospital can print a $2 specialized dose for somebody, then Big Pharma really can't justify a $1,000 sticker price that they negotiated with those middlemen that we talked about. But the reason why we're starting to hear about them more now is because there's a new reality. Drug shortages. I know this is fairly obvious, but when a major factory goes down or a supply chain snaps, people can actually die when they don't get their drugs. So the US government Equip a Pharma program, it's a massive partnership between DARPA and health agencies, is now pouring millions into this tech because in a crisis, a digital file is much harder to stop than a cargo ship. But it's not completely without risks. So as we move from physical pills to digital files in some cases, we're opening the door to a new terrifying crime. In one of my previous videos, I talked about how medical ID theft is a slow burn that can ruin somebody's life. But G-code hacking could be an instant kill. Researchers at Rutgers and Georgia Tech found that even if the software is secure, the printer itself can be physically hacked, where an adversary changes the sound or vibration of the motor to hide a toxic defect. And if a hacker gets into a pharmacy or a hospital network, they really only have to change one line of code. Maybe they change the infill pattern, making a 5 milligram dose act like a 50 milligram dose. Or they can change the print temperature, which could turn a stable chemical into a toxic one. But those same researchers are actually working on a solution to prevent this in the future. Researchers at the University of Copenhagen have already successfully 3D printed edible QR codes, so scannable digital signatures made of a drug-infused ink. Before somebody takes the pill, they scan it, and if that digital token doesn't match the blockchain record, the pill is flagged as corrupted. So we're literally going to get to a point where we have to verify our medicines the same way we verify a login on our phones. In all honesty, this might just be a minor niche way of making drugs, but on the other end of the spectrum, by the end of 2030, the era of big pharma as a manufacturing giant may change. The high volume, cheap drugs will stay in the factories, but many of those high value, life-saving medicines might become software, which could be a very good deal for Americans if it doesn't get blocked or stifled. If you found this video interesting, you'd like to see more like it in the future, please consider subscribing for more. This is Tyler Dutchover. Thanks for watching.